Okay, so for fractions, we're going to start off, this is the numerator on top, and then the bottom is the denominator. Denominator. This tells us how many pieces are shaded, and an example is you have a circle that is cut into 4 pieces, and I'm going to shade 1 piece, and then the denominator is the total number of pieces. So this is 1, 2, 3, 4. Our denominator is going to be 4, and our numerator is the shaded, which is 1. To find an equivalent fraction, you do to the numerator what you do to the denominator. So if I multiply this by 2, I multiply this by 2 as well. 2 times 1 is 2. 4 times 2 is 8. So 1/4 is equivalent to 2/8. And then you can do the same thing with any number you want. You can use 3, 5, 7, 10, doesn't matter. But anything you do to the denominator, you do to the numerator, and anything you do to the numerator, you do to the denominator. 1 times 3 is 3. 4 times 3 is 12. 1/4, 2/8, and 3/12 are all equivalent fractions. And then I'm just going to do times 4. Anything you do to the numerator, you do to the denominator. 1 times 4 is 4. 4 times 4 is 16. So these are all equivalent fractions. 1/4, 2/8, 3/12, and 4/16. If they give you part of the problem, like this, then you're going to figure out what belongs there. So how would I get my 2 to a 4? I would multiply it by 2. They already multiplied this by 2 because anything we do to the numerator, we do to the denominator. So in what times 2 equals 10? Or 10 divided by 2, so that is a 5. So that's what happens when you find the missing numerator or denominator. So let's try it when it is a numerator. So this is what we're trying to figure out, and this is what they give us. So because they gave us the complete denominator here and here, how would I change my 6 to a 12? I would multiply it by 2, and they already multiplied this by 2. So what would I do? I would do the opposite. What times 2 equals 4? It's division. 4 divided by 2 equals 2. Okay, to write something in simplest form, we are going to say, what does 2 and 10 have in common that we could divide by? When we're finding the simplest form, we are dividing by the number that they share. So 2 and 10, first, we know that the smallest number factors that both share is 1, but we're never going to divide by 1 because we would just get the same number. So if I divided this by 1 and this by 1, it would just stay 2/10. So the factors of 2 are 1 and 2. So we can't use 1 because that wouldn't do anything for us. So what can we do? We can divide both the numerator and the denominator by 2. So if we did that, we would do divided by 2. Anything we do to the numerator, we do to the denominator. 2 divided by 2 is 1. 10 divided by 2 is 5. Okay, let's try a little harder one. So 9/12. What does 9 and 12 share in common that we can divide by? Sorry, this is wiggly. I don't know why it's so wiggly. 9 has factors of 1. Does 3 go into it? No. Does 2 go into it? No. Does 3 go into it? Yes. Does 4? No. 5? No. So now we close it off at 9. So we only have to go to half of the number. Half of 9 is 5, 4.5, but we can't divide it by 4.5. So we are going to say we can't use 1. Does 3 share a factor with 9 and 12? And does 9 share a factor? So let's try both of them. 9 divided by 3 is 3. 12 divided by 3 is 4. So that is something that we can use. But we have to make sure that that's the biggest factor that goes into it. So the only one we have left is 9. 9 divided by 9 is 1, but 12 does not divide into 9, so we cannot use that one. So the highest number that we can use is 3. 9 divided by 3 is 3. 12 divided by 3 is 4. 3/4 is 9/12 at its simplest form. Okay, to find out whether this is going to be greater than, less than, or equal to, we are going to act like we're adding the numbers together, so we have to find a common denominator. Our common denominator is 6. How do I change my 6 to a 6? I multiply it by 1. Anything I do to the denominator, I do to the numerator. So 5/6. And then I can't just change a 3 to a 6. What would I have to do? Multiply it by 2. Anything I do to the denominator, I do to the numerator. 2 times 2 is 4. Now we can compare these two, and because they have the same denominator, we now look at the numerator. Which is the biggest numerator? 5. So it's 5/6 is greater than 2/3. We can also follow this same technique if we're ordering our fractions from least to greatest. So if we have 3/10, 4/5, and 1/4, we can look and see what denominator would work for all 3 of these numbers. So right now I look and I go, oh, 20, right? 5, 10, 15, 20. 4, 8, 12, 16, 20, 10, 20. So we can change all of these to 20, and then we say we can't just change a 10 to a 20, we multiply it by 2. Anything we do to the denominator, we do to the numerator. 3 times 2 is 6. 5 times what is 20? 5 times 4. Anything I do to the denominator, I do to the numerator. 4 times 4 is 16. Then I have the bottom one. 4 cannot just change to a 20. What do I have to multiply it by? Times 5. Anything I do to the numerator or the denominator, I do to the other one. 1 times 5 is 5. Now all 3 of these are the same denominator, so now we can look at the numerator. This is 6, 16, and 5. So the smallest one is this one right here. This is the least. This is the second least. And this is the greatest. So if they want you to do least to greatest, you're going to do 1/4, 3/10, and 4/5. If they want you to do greatest to least, you're going to do 4/5, 3/10, and 1/4. So make sure when you're looking at your page, you underline greatest to least or least to greatest. Okay, so adding fractions, we have 5/12 plus 4/12. Because it's already the same denominator, all we have to do is add our numerators together, and we put it all over 12. We never add our denominators 12 and 12. We just do 12, and this stays 12, so this is 12. Same with subtracting. As long as they have the same denominators, all we have to do is do 5 minus 4 is 1 over the same denominator of 12. When there are let's see, they don't have an example of this right now, but I'm sure it will be on the test, so I'm going to include it. 1/3 plus 2/5. We have to count by 3s and by 5s until we get a common number. And 15 is our lowest common number that we use for our denominator. So we change the 3 to a 15. I would have to multiply my 3 by a 5. Anything I do to the denominator, I do to the numerator. 5 times what is 15? 5 times 3. Anything I do to the denominator, I do to the numerator. Now I have the same denominator. So all I have to do is add the numerators. Okay, to change an improper fraction to a mixed number, like 9/4, I'm going to say, how many times does 4 go into 9? It goes in 2 times. This is going to be my whole number. And then I do 4 times 2 is 8. It's a remainder 1. I'm going to put the remainder as the numerator. And then I look at my original denominator, which is 4. To change a mixed number to an improper fraction, I do 4 times 3 plus 1. 4 times 3 is 12, plus 1 is 13. And it's all over the same denominator. When I am doing something that looks like this, which is adding mixed numbers, a mixed number is a whole number and a fraction together, I am going to make sure I have the same denominator, which I do. It's 6. So I know that my denominator is going to be 6. And then 5 plus 3 is 8. 2 plus 1 is 3. And then I have a problem here. My problem is this is an improper fraction. That means that the numerator is bigger than the denominator. So I have to change it to a mixed number. 6 goes into 8 one time. That becomes my whole number. 1 times 6 is 6. 8 minus 6 is 2. That becomes my numerator. And it's all over 6. But this is not my answer. This is this part of the answer. So I have to add this part and this part together. This is my whole number. And I'm going to add that to 1 and 2/6. 3 plus 1 is 4. And then I have nothing to add to 2/6, so I just rewrite it. And then this is a big problem because we have a lot of steps. We just take it one by one by one. So 2 and 6 share a common number, so we can simplify it or put in the simplest terms. 2 is my common number. I divide 2 by 2, that's 1. And 6 divided by 2 is 3. So my answer is 4 and 1/3. Okay, 6 and 1/8, or sorry, 6 times 1/8. This is your numerator, and it goes over 1. And this is your denominator and your numerator over here. So we always put a whole number over 1. 6 times 1 is 6, and 1 times 8 is 8. And we know that 6 and 8 have a common number that we can divide by. It is 2. We're going to divide this by 2. We're going to divide this by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So the answer is 3/4. Okay. So I'm going to do this problem right here. The table shows the heights of fence posts that the garden shop has in stock. There's 3/4 meters and there's 5 of them. So basically you're going 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. But that is a lot of work. So since I have 3/4, I can just multiply it by 5 over 1 and that will do the same thing. 3 times 5 is 15 over 4. So this is 15/4. This one is 2 times 5 is 10. And then 1.5, we have to change it to an improper fraction by doing 2 times 1 plus 1 is 3/2 times 2 over 1, which is 6/2. So I'm just going to put that here. And then I do the same thing for this. 4 times 1 plus 1 is 5/4 times 3 over 1. 5 times 3 is 15. 4 times 1 is 4. Now they want us to graph them. So you would do 15/4. Okay, so 10 is over here. 6 divided by 2 is 3. So that is right here. Oh, I see what they want you to do. Okay, I thought they wanted the total. So they want you to do 1, 2, 3, 4, 5, 1 1/4, 1, 2, 3, 1 1/2, 1, 2, and 2 is 1, 2, 3, 4, 5. If they wanted you to add them all together, then you can do that by finding, this would be 30/4 plus 3 plus 10. So we could do that. 30/4 plus 3 plus 10. So 3, let me do it on another sheet. 3 and 10 are whole numbers. And then we have 30/4, which we can simplify. 4 goes into 30 how many times? 7. 7 times 4 is 28. What's left over? 2/4. 2/4 equals 1/2. So this is 7 1/2. So now we can add all of that together. 3 plus 10 plus 7 is 20.5. Okay, here is a word problem that goes with the previous table. How many posts does the garden shop have? So all we have to do here is just add the number of posts. And this one, they don't care how big they are. They just want you to say how many actual posts are there. 5 plus 3 is 8, 9, 10, 15. So the answer to this would be 15. What's the difference in height between the tallest, which is 1.5, 2, 3/4, or 1 1/4? So first we find what is the biggest, 2. What is the smallest, 3/4? Okay, so we have to borrow because we have a 0 here. And if I have 0 cookies, I cannot give my neighbor 3/4. So I borrow from this. This becomes a 1. And then I take my denominator, which is 4, and I make it 4/4. Now I can do 4 minus 3 is 1 over 4. So the difference between the tallest post and the shortest post is 1 1/4. And then the label is meters. They said M right here, which is meters. There are 2 posts which are 1 1/2 meters tall. So we're going to add those together because they're asking what is the total height. 1.5 and 1.5 is 1 whole, 2, 3. So 3 meters tall. Okay, here is a word problem. Thomas has 8 packets of milk, so we can write that down. 1, 2, 3, 4, 5, 6, 7, 8. Each packet is 2/5 of a liter, so 2/5 plus 2/5 plus 2/5 plus 2/5 plus 2/5 plus 2/5 plus 2/5. So that's 8 of them. After pouring all the milk in a container, so let's find out how much milk he has total. 8 times 2/5 equals 16/5. He uses 1 4/5 liters of milk to make a dessert. So let's make this into a mixed number. 5 goes into 16 3 times. 3 times 5 is 15. 1 is the remainder over 5. So he has a total of 3 1/5 liters of milk, and he uses 1 4/5. If I have 1/5, can I give my neighbor 4/5? No, I cannot, so I borrow 5/5 and I add that to the original 1/5, and that gives me 6/5 minus 4/5. They have the same denominator, so now I just subtract 6 minus 4 is 2/5, and 2 minus 1 is 1. 1 2/5 liters is how much he has left. Mr. Garcia had some blueberries. He sold 2 3/4 kilograms of the blueberries and packed the rest into 9 bags. These 9 bags contained 1/4 kilogram each. So we're going to do 9 times 1/4 to find out how much that weighed. 9 times 1 is 9 over 4. So 9/4 plus 3/4 plus 2. 9 plus 3 is 12/4 plus 2 is 2 12/4. We can make this into a mixed number or a whole number if it goes in evenly. 12 divided by 4 is 3. So this now becomes a 3, and I can add the 2 and 3 together to get 5 kilograms of blueberries. Okay, Alex cuts a chicken pie into 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. He eats 1/4 of the pie. So 1/4 of the pie would not just be 1 because the denominator is 12 whole pieces. So what we have to do is we have to say what fraction would be equivalent to 12ths. Multiply this by 3. Anything you do to the denominator, you do to the numerator. So it is 3/12. So we would color in 1, 2, 3 pieces. Okay, Emily made some applesauce for a class picnic. Her recipe used 1/3 of a cup of sugar for each batch. This is equivalent to question mark over 12. So this is the one where we have to solve for this number right here. And they gave us 3 and 12 as the denominator. So I can just pretend like I'm adding it and do the same thing I would do for adding. This is a 3. I can't just change a 3 to a 12. What would I have to do? Multiply it by 4. Anything I do to the denominator, I do to the numerator. So that would be 4/12. Sorry, I need a sip of water. Too much talking here. Okay. Next one is Emily made 5 batches of applesauce. How much sugar did she use in all? So each recipe called for 1/3 cup, and she made 5 batches. So 5 over 1, and we multiply it across. 1 times 5 is 5, 3 times 1 is 3, and then we change that to a mixed number. 3 goes into 5 how many times? 1. 1 times 3 is 3, and our remainder is 2, so that becomes our numerator, and it's all over the same denominator. 1 2/3 cups of sugar. Okay. Which 2 fractions are equivalent to 1/3? So we would find what the denominator is. So I have 1/3 is what I'm looking for. Well, we already know 2/3 is not it because it has the same denominator, and 1/3 and 2/3 are not the same. I can cross that out. Now I'm going to find out, is 2/6 a possibility? So here's my denominator. I would multiply it by 2. Anything I do to the numerator, I do to the denominator, and vice versa. 1 times 2 is 2. So is that true? 1 times 2 is 2. 3 times 2 is 6. Yes. So B is a possibility. That is one of our fractions that is equivalent. Our original fraction is 1/3, so we're going to put 1/3, and then we're going to find out, is it equivalent to 3/6? So multiply by 2, multiply by 2. Is 1 times 2 3? No. So C is not an answer. 1/3, and then they're saying, is it equivalent to 3/12? If I multiply 3 by 4 to get it to 12, is 1 times 4 3? No. Next one is 1/3, and they want to know, is that equivalent to 4/12? If I have 3 and I multiply it by 4 and I multiply the numerator by 4, is 1 times 4 4? Yes. So the answer is B and E are equivalent to 1/3. Okay, so for this one, which expression is equivalent to 4 times 5/8? So I'm going to figure out what the answer is to that. I multiply my numerators across and my denominators across. And then I can do the same thing for all of these to see which one is equivalent. So I'm just going to write all of them down. And then I'm just going to multiply across for all of them. And it says which expression. So there's only one answer here. This is 8/5. This is 9/8. This is 20/8, which is what our original answer was. So my answer is C. Okay, the last one we're going to do is Jason had 1/3 meters of ribbon. He bought another 2 2/5 meters of ribbon. What's the total length? So because they're saying that language, we know that that is adding. He had something and he added something else to it. So we have 1 3/5 and 2 2/5. This has the same denominator. So we rewrite the denominator down here, and then we do 3 plus 2 is 5. 3 plus 1 is 3. This is 1 whole, so we add that to the 3. It equals 4. And then meters is the label of ribbon. Okay, honey, go in with confidence and just try your best, show all your work neatly, and try to follow one step at a time. One step, one step, one step. You've got this. All right, darling, good luck. Bye.